Hi, this is Professor David Farina. In today's lecture, we're going to be discussing the terrestrial planets, atmospheres, and atmospheric evolution. Let's get started. So, to start us off, let's go from the very, very smallest planet in our solar system, the planet Mercury. Mercury has no detectable atmosphere. It's far too hot being so close to the sun, and far too small to have the necessary gravity to hold on to an atmosphere. So, Mercury is an airless world. And in almost every way, it's very similar to our moon as a result. Next up is the planet Venus. Now, although Venus is closer to the sun than the Earth is, the planet Venus has a very thick atmosphere. It has an atmosphere that includes clouds, and the clouds are a similar temperature to that of Earth. However, as we look below that cloud layer, we realize that the temperatures below Venus's cloud layers are upwards of almost 900 degrees Fahrenheit. This is hot enough to melt lead. And in fact, the Soviet Union, the former Soviet Union, has the record of landing the only spacecraft on the surface of Venus, and that spacecraft only lasted a few hours before it was no longer functional due to the high pressures and temperatures of Venus. The atmosphere of Mars is about 1% the thickness of Earth's, and the atmosphere is made mostly of carbon dioxide. It's thought that in the past, Mars may have had an atmosphere very similar to the Earth. Once again, Mars does include clouds at times. Mars also includes some dust storms, wind, and even some precipitation, possibly in the form of frost. So, at the beginning of our solar system, it's thought that the planets probably had some sort of primitive atmosphere, mostly made of hydrogen, helium, methane, ammonia, and water vapor, which, as a result of the early solar system's very active sun, was likely lost. A secondary atmosphere was formed on some of these worlds, and was primarily in the form of water vapor, carbon dioxide, sulfur dioxide, and nitrogen, which is coming from the internal volcanic activities as the planets differentiated, as we discussed in previous videos. So differentiation, just to refresh your mind, is when the planets are changing their densities towards more dense towards the core and less dense material towards the surface when they're in their molten state. As their molten state cools off and the volcanoes are releasing these gases towards the atmospheres, that's when a secondary atmosphere would be made. Now, Earth, we think, has a tertiary atmosphere where it includes 20% oxygen due to the presence of life. This is something that possibly could have had a chance to change Venus from its state that it's currently in, but it appears Venus was just a little bit too close to the sun for this to occur. It was just outside the habitable zone. Now, Earth does include a small greenhouse effect. As we've discussed in previous videos, the temperature of the Earth would be very, very cold, below the freezing point of water, if it were not for the greenhouse effect, which is a naturally occurring process. However, it's important to note that this greenhouse effect, although natural, can be thrown off balance by human activity, as we're finding out with climate change. Venus's atmosphere, on the other hand, has gone to the other extreme. Venus includes significant amounts of carbon dioxide, and as a result has what we call a runaway greenhouse effect. In a runaway greenhouse effect, the temperatures are able to reach extreme levels, and the pressures are also able to reach extreme levels as the interaction between sunlight and the thermal radiation produced is out of balance, and it turns into an oven. Thanks for watching today's video on the terrestrial planets, atmospheres, and atmospheric evolution. If you like this video, please click the like button. If you'd like to learn more, please click subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks again, and have a great rest of your day.